So when you start doing, so if you're a math major, after Cal 3 and differential equations, we start to do what math is supposed to be. It's proving statements using logic and ideas and theorems, lemmas, all that stuff. So it's kind of like, I'll have to phrase it here. Kind of become like a lawyer, trying to argue you're trying to use all your evidence to prove something is true. Okay. I know like 500 years ago, a lot of lawyers did math on the side as a fun project, and they actually wrote books and stuff. So famous lawyers or famous mathematicians were also lawyers, and it's because they need that logic. Okay, it's very important. So we're going to use our logic and our theorems to prove that the statement is true. So that's what math becomes later on. I'm not saying you'll ever see that, assuming unless you're a math major or you go to grad school and you're doing engineering or physics. And once you get to grad school, it's all theorem proving type of stuff. Okay. But if you're not going that far, you may not see this, but this is the first taste of it. It's a very basic type compared to the high level stuff. So which all you have to do is choose a side and then make it turn into the other side using what is true, using the definitions, properties, theorems. Okay. The rule of thumb is choose a side that is the most complicated. Don't choose the easy side. Because like, for example, this looks simple, right? The right side. Trying to make a sign turn into this requires a lot of out of the box type of thinking. Like you have to be very creative to transform this into this. It's possible. I don't recommend it. If you start here, you have more things you can try because you have more to work with. Okay. So start there and decide, what do I do? How do I get to sign? So you look back at your theorems, your identities, your properties. So I don't have anything squared, so I probably shouldn't worry about Pythagorean, right? I don't have any negative angles inside, so I'm not going to worry about even or odd. It's going to be between these two. Try a property from here. What do you think would be helpful? Yeah, I think quotient would be the best. So when you're doing this and you're not sure what to do, because that's going to happen, you're going to stare at it and be like, I don't know. Just try something. See what happens. Okay, don't just stare at it. Just look at what you have and transform it. Try something. We know tangent is equal to this, right? If it turns out you go down a strange path and it's just getting worse and worse and more complicated, then you chose the wrong beginning. Try something else. Start over. And that's okay. Sometimes you can find the end if you keep going, but it's a lot like programming. There's many ways you can solve these, but there's always a simple way. But if you miss it, that's okay, as long as it works. Okay. So right here we used the quotient. I'm going to make a note every time we use something. Quotient identity. So as you can see, right, sine theta times cosine theta is going to cancel this guy. So now we're exactly where we wanted to show. So once you prove that this is equal, that this guy is equal to this, now this is basically a formula that this is true. So you can use this anytime you want. Okay. So when you prove something, you know it's legit, so you don't have to worry about it. That's the idea. So all the formulas, definitions, and all the math books, physics books, all that stuff, they were proven by somebody using logic, okay, using definitions. And creating them can be a lot of work. Like creating a really powerful theorem, it's like basically like a PhD project. Okay. Anyway, yes. Yeah, we're trying to show that these two are in fact equal. So you choose a side and you get to the other side. In essence, that's all we're doing. But you have to use properties that are in the book. So you're going to use algebra and your identities. Okay. Let's do another one. So we're not solving for anything. We're just proving things, verifying things. Okay. So 1 plus sine times 1 plus sine negative x equals cosine squared. So what side would you choose to start? Yeah, the left side looks difficult, so we should try to see what we can do with this. Okay. So here we go. Just gonna write down. So whenever you solve these, I want you to write down what side you're starting with and then decide what you want to do. Don't use the other side once you've chosen. Okay. I don't see any squares, so I don't think we should do Pythagorean, right? What do you guys think? What would you use? Yeah, we see a negative angle, we should right away think, let's try something with the even or odd. We have a negative sign, right? Or sine negative something. So pull out the negative. That's what we're going to do right here. I'm making a little note here too. Tangent theta is sine over cosine. So 1 plus a negative sine x. So from here to here, use even odd property or identity. Because sine of negative x is equal to negative sine x. You guys okay with this so far? We're just trying something and see what happens. Okay. At this point, plus and negative is the same as just minus, so let's not write it that way. When you see this, does this make you think of something from algebra? Yeah, well, for sure it's a multiplication, right? Do you see that it's a conjugate pair? And this is always going to multiply as the first term squared minus the second term squared. From here to here, difference of squares from algebra. So whenever you have something plus something times that same thing minus that same thing, it will always be this way. If you don't remember that and you just FOILed it out and multiplied everything, you're going to end up with this, no matter what. So even if you forgot, it's cool. I'm just trying to save you time. So now we have a square. So look at the Pythagorean identities. What is this equal to? Yeah, that is cosine squared, right? So we've arrived where we wanted to go. Pythagorean. Identity. Cosine squared theta is equal to 1 minus sine squared. Do you see the thought process? Right, every single change has something backing it up. Okay. So we're basically forming like an argument. Any questions on number 1 or 2? Is it okay?
You took the square from the one for just.
Yeah, 1 times 1 is the same as 1. 1 to any power is 1. Doesn't matter. Pick another one.
The brackets are just to separate the other equation.
These brackets?
Yeah.
Yeah, it was just for organization. It looks a little nicer when you have parentheses and brackets. Although I'm hoping these brackets are not confusing out here. This is just me telling you from here to here, I did this. Here to here, we use this. Is that clear? Okay. Any other questions? You guys cool on this page then? I'm gonna turn the page. Okay, do a few more. Third one. This one has a ton of squares. Obviously, we want to choose the left-hand side, right? So this just looks disturbing. So let's start there. What is secant squared minus 1 equal to on your formula sheet? Yeah, it's going to be tan squared, right? Okay, we got tan squared. So from here to here, we use the Pythagorean. Okay. Now, when I see these, I know tangent is sine over cosine, right? And this is 1 over cosine. So we have two fractions. So if we change them to fractions, we can multiply and hope something cancels. So my idea at this point is change the tangent and change the secant. So from here to here, we use this identity. And this identity. I believe it's the quotients, yeah, quotient. Oops. And this is the reciprocal. So I went ahead and changed the tangent and the secant at the same time. Is that okay? I did 2 steps in this one. So now you see that cosine is going to cancel, right? Which is what we want. We want just the sine to be left over. We don't want any other terms. So if we show the algebra step or the fraction step, we would get this. Which is what we wanted to show. All that garbage is equal to sine squared. Any questions about this? Yes.
Whenever we go to homework, do we have to show like every scenario?
I think you should, yeah, make a note of what you used. That way it'll help get stuck in your head so you know what you're using, what you're doing. You gotta show all your steps, okay? So let's do some homework. Let me pause this. Alrighty. Dark. To verify or simplify, in this case, it's just simplify. So the first thing I'm looking at is that negative angle. So try one of those identities. So right here, cosecant will probably do something with that in a second. So this becomes a negative cotan x, right? That will be the same as minus cosine cotangent. Just put the minus in front because positive times negative is going to be negative. So right here we used even and odd. What do you guys think? What would you do after this step here? Yeah, I think that might be good. Let's see. Because cosecant is equal to what? 1 over, yeah, 1 over sine and then cotangent. Okay. So now that we have fractions, a good hint is add the fractions. When you add them, stuff is going to happen or powers will increase. So either create the fractions yourself, or if they do appear, just combine them. You're always going to want to add fractions. Okay. So from here to here, we used quotient and I think it was ratio. No, reciprocal. Okay. To simplify a little bit, this is 1 over sine minus cosine squared x over sine x. Luckily, we have the same denominator. We don't have to do anything extra. Just combine them into one fraction, right? Nothing you haven't done before. If they have the same denominator, you just combine the numerators. And we get to here. At this point, I'm hoping this triggers your mind a little bit. You see a square, what should we use? Yeah. Yeah, it's going to be the Pythagoreans. I think someone said sine, right?
Yeah.
So at this point, what happens? Right. We simplify it all the way. We get just sine. So all that garbage was just a sine. So just try something. I know it may feel intimidating at first. You end up staring at it. Just try something. See what happens. Believe in your algebra skills. Okay. Any questions on number 5 or 8?
To me, is like negative. Why the term are they to I guess it's negative cosine.
Because they're being multiplied. Like if you had a 2 times negative 3, it would be negative 6, right? Same thing. A times negative b, negative ab. Positive times negative. Yes.
We have the cos of x times square of x over sine x. We just have to multiply with cos dr to What's right at the bottom?
Yeah, it's not on the bottom. It's over one. Yeah, there was never two of them, right, at the beginning? Yes.
I'm kind of confused on where you went from one minus cosine, square root of sine.
Oh, it's the formula. Look at the very top of your Pythagorean. Sine squared is equal to 1 minus cosine. Once we change this into this, it canceled one of the signs. So you go as far as you can. You should always end up with something pretty simple. If there's too much stuff going on, then you're not done. Like for example, what's the next problem? Number 10. You should end up with the number 3. All that simplifies into a 3. Which is surprising, right? But using your identities and properties, stuff will cancel and combine. How much time we got? So good. You guys cool on this page? Okay. Or sorry, I meant this one. Where is it? You already got this part. All right, and I'll switch back then. 10 is the next one. 10 simplifies into the number 3. The answer is 3.
So we're doing the homework. Get everything.
No. I'm just trying to help you out. After 15, though, they do tell you where you're supposed to end up. So this section, they tell you. The last few, you're proving statements. Yeah, these are the homework problems. So when you do this homework, you're gonna look up the PDF of the book and go to those questions I wrote down. Okay, show all your work and scan it. I think Sunday the earliest, but I haven't posted a date yet. We'll see. So change cosecant into 1 over sine. What should we do next? Yeah, even odds a good idea. Okay. This would become 3 sine cubed over sine, right? Plus cosine. Even this, all even functions absorb negative, so this is the same as 2 cosine times cosine. So then we get, this will reduce into 3 sine squared plus cosine plus 2 cosine squared. So far, is everyone with me at this point? So we have 1 plus 2. They both have 3 in common. What is sine squared plus cosine squared? So this is a 3. All this is just a 3. Any questions on this example?
So sine squared plus squared.
Yeah, that's the first formula we wrote, the very first Pythagorean. Any step not make sense. Oh, the even and odd, this is the same as a regular cosine.
Wait, can I show you?
Sure, yeah.